All right, but with a slight bit of manipulation, it will. All right, so I could rewrite this as x to the negative fourth dx. All right, we're going to later on in the unit, well actually in the next unit, develop a good understanding of where the funky s comes from. For now, it's just a symbol that means antiderivative or integrate. So we think of it as an operation or a command. Right? So when you were introduced to the concept of a square root, you didn't particularly care necessarily. I mean, I did, but not enough to voice my concern in class. Like, okay, so where did that little check house thingy come from? Like, not the need for it, but like that symbol. Like, why that? Yeah, so, but for me, I think of stupid things like that. Some people would not consider that to be stupid. I don't know. Everybody I've ever said that concern to has said, okay, listen, you got to find better things to do with your time's out. So, but it has concerned me, but I will say not enough to actually find the answer to that question. So, I'll offer it to you. Through the Remind app, as usual, the first person that gives me the history of the symbol for the square root will get a bonus point. All right. Oh, paying attention. The first person, yeah. All right, it's first come, first serve. All right, so it's the power rule, but in reverse. So I'm going to increase my exponent by 1. Making it x to the negative third. I'm going to divide by my new exponent. Now there's an understood coefficient of 1, so if I divide that by my new exponent of negative 3, it's going to become negative 1/3. I'm just going to tack the negative on the top just because that's how math works. Yeah, I mean, technically you can write it as 1 over negative 3. It just doesn't look as nice. What's the one thing I'm missing here? C. The plus c. All right, so what do we have here? 8 problems on this page. So if I gave you like these 8 problems on a quiz or a test, and you didn't write plus C in each case, you'd lose half a point in each instance. All right, so it's a total of 4 points that you're just throwing away for something very simple. All right. Historically, it's always happened to one person in every class. I'm hoping that by bringing it up repeatedly, I can get that down to 0. All right, so that's with permanent marker. You know what I should do is like I should like change my last name to like plus CANN. So like it'll just be right there and just see it all the time. Okay. Yeah, no, now it just sounds weird. Yeah.
It sounds like some kind of like entertainment service. TED Plus.
CAN is like everything you could ever want in media. Like I don't know. It's like I don't know. It's like a person who kind of got to email late in the game. You know, like, okay, so there's no TED cans anymore, so I guess I'll just do TED plus can, like, or underscore. Ooh, underscore.
Or just like whenever you like write a whenever you like write C, like the letter C, just add a plus before it, like
just
in all instances.
Plus calculus everywhere.
No, just have a plus C and don't explain it until we get to this.
Like, why is it always like that?
No, it's so cool. Typo, there's no frozen. I thought you were right.
Excellent.
Now you just got to know to look for it. All right. Magnificent. So this one, number 2, it's a little funkier because it's got a lot of ingredients. Now, technically, we could think of this, and this is really where it starts to get a little weird, but it's not difficult in its weirdness. It's just weird. So it's the integral of the difference or sum between different functions. Technically, that's the same as the integral of each one of them, added and subtracted as appropriate. So in reality, we're looking at something like this. All right. Now, on a test, quiz, AP exam, you would not have to write it separately because in the next step, we would integrate and then put it all back together anyway. All right. So the antiderivative of 3 to the x would be what? Exactly. Technically a plus c, but we're going to leave that off for a minute. Antiderivative of e to the x. E to the x. Antiderivative of x to the third. One-fourth x to the fourth. Plus x to the e as an antiderivative. X to the e plus 1. It's a little trick question or attempt at a trick question. And then I'm going to put a plus c off at the end. All right. The reason I can do that is what we talked about yesterday, is that if you have a plus c for each part, if I take all those constants and add them together, what am I getting as a result? Just another constant, right? And we would denote that with a c. Right. In which case, if you had plus 4c, if they were exactly the same constant, it would be a constant multiplied by a constant, because 4 is itself a constant, the result of which would still be a constant. Right? So that's why we call c the absorbing constant, because it absorbs all other constants like a gravity will. I was watching Star Wars Resistance last night. They had gravity wells involved, so it's on my brain. Antiderivative of 5 cosine x. 5 sine x plus c. Now, number 4 takes on a different form. Find a general solution for a differential equation. Right? So instead of dr d theta equals, we want r equals. All right, solution is it's not the differential form or a differential equation. It's the function that preceded that. All right, so in order to do that, I would get it into differential form first. Dr equals pi d theta. Then I would take the antiderivative of both sides. Now, in front of the dr, we have an understood coefficient of 1. We'll integrate both sides. What's the antiderivative of 1? Well, the derivative of 1 would be 0. If we were dealing with y's and x's, it would be y, but here we're dealing with r's and thetas, so r. Normally I'd say plus c, but I'm just going to consolidate this c with the one that's on the right anyway, so I'm just going to leave it off. Antiderivative of pi. Well, that would be derivative. Pi x, so pi theta. All right, variables theta plus c. All right, that's the general solution. We haven't talked about particular solutions except to say that they exist. A particular solution would be the case where we actually determine what the c value is. All right, we're not there yet. That's something for tomorrow.
Did you want us to remind you the order of the square root symbol?
Yeah, send it on reminder. All right. Oh, by the way, does anybody know what kind of equation this is? Something from pre-calc. You may or may not have seen it. Something that has r's and thetas instead of x's and y's.
Oh,
Polar.
sir.
Polar. So there is a place for polar equations, polar coordinates in this. In the North Pole. That's where we keep them all. There's a warehouse up there we store them in. It's a little bit ahead of the game, but the reason why I throw in a problem like this is because I wanted you to understand that calculus can be applied in different coordinate systems. So not just x, y, but r's and thetas, right? I'm testing tonight in my Calc 3 class on the derivatives and antiderivatives, like a full-blown unit related to polar functions or polar graphs. And so, obviously, what does that mean for you? It means you're a little ways away from being exposed to that in its full, to its full potential. But, just understand that this is something that you could look at also. Rates of change associated with polar graphs, parametrics we looked at when we did the basketball activity. And we'll look at parametrics again before the course is over. But, there's different applications to this stuff that span beyond two-dimensional coordinate systems, right? Because you think about the real world. I think 2 dimensions are a subset of everything else, but it's not the entirety of it. You look outside, you got length, width, and height, right? And then the passage of time to kick in a 4th dimension, and so on. All right. So between now and I guess Tuesday, you're going to want to tackle the remaining problems on this page. They require you to do a little simplifying first in some cases, but generally all of the processes that we talked about can be applied to these 4 questions. All right, so we haven't learned anything like a reverse of the chain rule or product rule or quotient rule yet. So simple, basic antiderivative rules can be applied to any of these questions. All right, so between now and Tuesday, you're going to want to tackle these problems. All right.